Welcome to qnawire.
All right, we're going to find the sine of 2 times the arc cosine of x. First of all, remember your double angle identities. The sine of 2 times an angle equals 2 times the sine of the angle times the cosine of the angle. Okay, arc cosine x means the angle whose cosine is x, so I'm going to call it theta. So we're finding the sine of 2 theta. Now the angle whose cosine is x, what would that look like? There are two possibilities. One possibility is that the angle is in quadrant 1. Another possibility is that the angle is in quadrant 2, its terminal side in quadrant 2. So let's look at both cases. If the angle is in quadrant 1 and its cosine is x, then we could put x on the adjacent and 1 on the hypotenuse because x over 1 is x. And if the angle is in quadrant 2, we can do the same thing. X on the adjacent, 1 on the hypotenuse, we still have x over 1 is x. Now let's find the length of the opposite, because we're going to need that in order to find the sine. So for now, let's call the opposite y, and it's going to be y on the other side as well. So now we can use the Pythagorean theorem, and we have y squared plus x squared equals 1 squared. So y squared equals 1 minus x squared. So y is the square root of 1 minus x squared. Okay, now we can work with this formula here. To find the sine of 2 times the angle, we want 2 times the sine of the angle times the cosine of the angle. What's the sine of the angle? Opposite over hypotenuse. So that would be square root 1 minus x squared over 1. And what's the cosine of the angle? Adjacent over hypotenuse. So that would be x over 1. So now we can simplify this, and we have 2 times x times the square root of 1 minus x squared. And then just keep in mind that the inverse cosine, or arc cosine as we're calling it here, function is only defined for x between 0 and pi. So we might want to make a note of that. X is in the interval from 0 to pi.